Okay, so these 5.12 notes, you're just going to work on some notebook paper. I'm just going to work through a few examples. And pretty much everything I'm going to cover, you already know how to do. We're just going to fine-tune some things and make sure everybody's good on notation. So let me just go ahead and start with an example. Let's say we have 2 sine of theta plus 47 degrees equals 1, and I want you to solve for theta. And from now on, I'm going to kind of give you a statement over here. Now, it used to be you had to find general solutions and particular values. What we're going to start doing here is I'm going to give you something like this, and this just means thetas that are in the set of the interval 0 degrees to 360 degrees. So my final answer isn't even the general solutions. That's just part of the work. My final answer here are all the values of theta between 0 and 360 that make a true statement here. Okay, so as I'm looking at this problem, I'm thinking, okay, how do I solve this? And there's a lot of formulas that we could use here, but you don't really want to unpack sine A plus B here. What we want to do is divide by 2. We get sine of theta plus 47 degrees, and that's going to equal 1/2. And now I've isolated the sine, so using inverse sine, I have theta plus 47 degrees is equal to arc sine of 1/2. And let's go ahead and write or start our general solutions. That won't be my final answer, but it is part of the work. And so this is going to give me 30 degrees plus 360 degrees in. And then I have another general solution that I need to write now. I don't need to wait until I've subtracted 47 to write it. And I got to think, well, where else is sine equal to 1/2? And that's going to be 150 degrees. Okay, if you're still having a lot of trouble with this, please ask me a question about particularly how to find that second value right there. Okay, so now I need to subtract 47 from both sides. So then I get theta is equal to, that's going to give you negative 17 degrees plus 360 in. And then when I subtract 47 over here, I have theta is equal to 103 degrees plus 360 in. Okay, so now let's talk about values of theta using the 2 general solutions that are between 0 and 360. Well, the first value I would pick would be 103 degrees. Okay, from over here. Over here, if I add 360 or plug in a 1 in for n, I should get 343 degrees. And then if I tried to continue to go any further, I would be outside of the span that they told me. So here are my 2 answers. And on these, there's really no telling how many answers you're going to have when you first look at the problem. You really just got to go through and work it out. Okay, let's try another problem. Okay, let's say I gave you 4 cosine squared theta equals 1, so another degrees problem. And this time I tell you that theta is in the set of 100 or negative 180 degrees to 180 degrees. Okay, so a little bit different. This time I might actually have to subtract because I'm not starting with 0. We'll get to that part in a minute. Okay, so first thing, okay, I needed to divide by 4. So then I would have cosine squared theta is equal to 1/4. And now to get just cosine theta, I'm going to take square root of both sides. Now, one thing you've got to be careful of here, when you take square root of both sides, you got a plus minus. Okay, so I've got cosine of theta equals 1/2, and then I've got also where cosine theta equals negative 1/2, and I'm going to write them out separately and solve them separately. Okay, it has to be like this plus minus because both positive and negative 1/2, when you square it, would give you 1/4. Okay, this brings us back to pre-AP Algebra 2. Okay, so then I have a theta is equal to an arc cosine of 1/2, and then I would have theta is equal to arc cosine of 1/2, that is a 60-degree reference angle, and so we're in degrees, so I got 60 plus 360n. And then I've also got negative 60. That's in quadrant 4. I could have put 300 here as well, but probably most of you would be thinking negative 60. And then something very similar over here. I have theta is equal to arc cosine of negative 1/2. So I need to be thinking about, well, what are the quadrants? It's still a 60-degree reference angle. But what are the quadrants, or what is the angle in quadrants 2 and 3 where the ratio here is negative? So then I would have 120 degrees plus 360n. And I would also have, you could write this as, you know, our next number needs to be in the third quadrant. So you could think of this as 180 plus 60, or you could think of this as negative 120. I'm going to go ahead and write it as negative 120 because I know that that's a good value, but you could have used the coterminal angle here. Now I have 4 general solutions, so let's start with the smallest value. Now normally that would be 60, but I'm not wanting to go from 0 to 360. I'm wanting to start with negative 180. So actually negative 120 degrees is probably going to be my lowest one. Okay, and then negative 60 degrees. Okay, so then 60 degrees, and then 120 degrees. And if you could add 360 to any of these or subtract 360 and get more values, then you would want to do that, meaning if you could plug in a 1 or 0 or negative 1 in here and get extra values, you would want to do that, but you can't here. These are your values. Okay, let's try another one. Alright, let's say, here's another situation. Let's say we had tan theta, secant theta equaling to tan theta. And again, this is theta, but this time I say that theta is in the set of the real number of degrees. This just means general solution. Okay, so just get used to this notation. Just means find the general solutions and that's it. Alright, let's even write this down. Okay, that right there means general solution. You don't even have to find the particular values. Okay, on this problem, you might be tempted to divide both sides by tangent theta. If you do that, you will lose solutions. Let me prove to you in a much simpler example of why that might be. Let's say you had x squared equals x. Okay, what do we know the answers have to be? Okay, 0 squared equals 0. That's an answer. What else? What else squared equals itself? 1. Okay, if I were to have divided by x to actually solve this, I would end up getting just x equals 1, which is great. That was one of my answers. But I missed out on the other solution. So really, the way you should solve a problem like this, besides guess and check, which is what we did, is you should subtract and factor. So then that would be x minus 1 equals 0. So that's how you get your 2 solutions. Okay, I went through that quickly, but hopefully you caught up. Rewind it and listen to that again if you need to. So on this problem, I cannot just divide out tangent theta. What I need to do is subtract tangent theta over here. And I need to factor. Okay, the nice thing about 0 is that it's going to work out really nice. Because if I have 2 factors that are equal to 0, well then I can continue to solve just by setting each individual factor equal to 0, because 0 times another number is 0, so you can work it out this way. And so here I have theta is equal to arc tan of 0. And so what is that? Okay, so that's 0. Well, that's one of my solutions. So I'd have 0 plus, this is theta, so, oops, back it up, sorry. As soon as I started writing that, I realized it was wrong. So 0 plus 180n. I could have also used 180 if you're thinking of the OIO chart, But think about 0 plus 180 is 180, and you don't even really need the 0 here. You could have just written 180n. All right, and that's what I'm going to actually write here below it. Okay, and n here could be positive or negative. Just we know that, but just to reiterate it. Okay, here I have arcsecant of theta equals 1. Well, this is just like saying arc cosine of theta equals 1. Now, generally, we'd have to change this number, take the reciprocal, but in this case, the reciprocal of 1 is 1. So then I would say that theta is equal to arc sine of 1. And where is cosine equal to 1? It's equal to 1 at 0. You can use that OIO chart. You can think about the triangle on the quadrantal axis. But we would have plus 360n. Now, at this point, whether you're using quadrants, which this is the only place, or whether you're using rules, -0, hey, that doesn't, I don't need to do anything else. The only other thing you could come up with here for your second general solution would be to put a 360 here, although those are coterminal angles. So then what I end up having is theta is equal to 360n. So these are my answers. Now, is there either one of these that actually takes care of the other one? Like if we really just wanted to be simple about our answer? Yeah, this one right here, theta equals 180n. If I really thought about it, that takes care of all the multiples of 180, take care of all the multiples of 360. So I wouldn't really even have to put in the general solution. Okay, I could totally get rid of it. But you don't have to. If you left it, it wouldn't be wrong. Okay, but just to kind of really fill all this stuff out. Just wanted to point that out. Okay, let's try another example. Okay, so let's say we had 3 minus 3 sine x minus 2 cosine squared x is equal to 0. And I see x, that tells me that I'm in radians, and I'm going to go ahead and use negative pi to pi. So in the end, I want all the answers that are between negative pi and pi. Okay, so I noticed a couple things about this problem. It looks like this is a trinomial that I possibly could factor, except that I have a sine here and a cosine squared there. So the first thing I'm going to do here is plug in a 1 minus sine squared. And let's go ahead and figure out what we have left here. We have 3 minus 3 sine x, and then minus 2, and then plus 2 sine squared x is equal to 0. And I'm actually going to rewrite this where the sine squared is first, then just the sine term, and then 3 minus 2 is 1. And let me clean this up just a little bit, make sure that that everybody can read what all this is. That's a 3 and that's a sine. Okay, there's something that you learned about last year called U substitution. And this is where you say let U, or you could really use any letter. And in this case, I'm going to let it be sine x. Okay, so this would be 2u squared minus 3u plus 1 is equal to 0. And we now need to factor this trinomial. It's just a little bit easier to look at when you're not having to deal with the sine squareds. Okay, so now hopefully you guys could factor directly into this, but I know factoring is not a strong suit. So I'm going to actually review the grouping method because I know that that will hopefully ring a bell. And so you go 2 times 1, that's 2. And the factors of 2 that would add up to -3 would actually be -1 and -2. So if you rewrote this problem, 2u squared minus 1u minus 2u and then plus 1. And then we need to factor out a u. I get 2u minus 1. I want another 2u minus 1 over here, so in order to do that, I need to factor out a -1. And I am left with u minus 1 into u minus 1. So you might be thinking, oh, factoring, I thought we were done with that. Well, you're not done with it, and you never will be. Factoring is something that you're going to have to remember for a long time. So there's a little review of it. Okay, so now my actual answers for u would be 1 and 1/2. Okay, so now let's go back through and let's substitute back in what u is equal to. U is equal to sine x. So now I have sine x is equal to 1 and sine x is equal to 1/2. So that means that x is equal to arc sine of 1. Okay, and x would be equal to arc sine of 1/2. Okay, so where is sine 1? Okay, 90 degrees, which would be pi over 2. So I could say pi over 2 plus 2 pi n. And if you tried to write a second general solution, if you use the rule, you would do pi minus pi over 2. If you thought about, and that's because this is a quadrantal angle, anytime you use your OIO chart, you're going to run into this issue. You cannot write a second general solution that isn't in turn equivalent to the first. Okay? And over here, you would have 30, which is pi over 6, plus 2 pi n, and in this case, I can write the second one. Okay, so in what other quadrant would be sine b positive 1/2? Well, that'd be second quadrant, so then I have 5 pi over 6 plus 2 pi n. Now remember that we were trying to find, let me pull all this down, we were trying to find all the x's that were between negative pi and pi. Okay, so let me rewrite this over here. X is in the set of negative pi to pi. Well, I know that pi over 2 is an answer, and I know that 5 pi over 6 is an answer. And I'm going to stop there as far as adding pi. But I can actually subtract pi to get answers in the front. Okay, so, or I'm sorry, if I subtracted 2 pi, could I get, let me rephrase this. If I subtracted 2 pi, okay, what would happen if I subtracted 2 pi from pi over 2? Well, you'd get negative 3 pi over 2. All right, is that within this span from negative pi to pi? No. Okay, so we don't want to go there. What about if I subtracted 2 pi from 5 pi over 6? That would be negative 7 pi over 6. Is that within this? No. Okay, so these two values end up being the only ones that I take. Okay. So here I have 1 plus cosine theta over sine theta is equal to negative 1. And I don't want to spend a whole lot of time on this. I'm actually not even going to completely solve it out. But I do want to talk about some different ways that we could work out this problem. If you're looking at this and thinking, wow, that looks a lot like the tan half theta formula, that is definitely a way to work this out, and I think the easiest way to work it out. Okay? You could actually also, multiply both sides by sine theta and get 1 plus cosine theta is equal to negative sine theta. Okay? And you could get this into something that you would want to then use linear combination on. Okay, so if you think about it, we have now a sine term, a cosine term, and a number. I definitely think it would be better to solve this using the half angle identity, though. Probably much easier. All right, I'm actually not going to finish that one. Okay, let me put up a different problem. And this is more review. Sine 3 theta, or cosine 3 theta, cosine 12 degrees, and then minus sine of 3 theta. Oof, that's messy looking. Here we go. sine of 3 theta, sine of 12 degrees, and let's say this is equal to 1/2. And I'm not putting here what you need to put theta in between, because that could just change throughout the problem. But what are you thinking when you see this problem? How are you going to go about solving this? Okay, hopefully you're looking at sum and difference properties and you're thinking, hey, this is cosine A plus B, so that would be 3 theta plus 12 is equal to 1/2. And then from here, you're ready to say that 3 theta plus 12 degrees is equal to arc cosine of 1/2, and then you're good to go to work it from there. Okay, let's look at another one. And it's the starting of these problems that is the most interesting part. Okay, let's say you had sine of 90 minus theta all over sine of theta is equal to negative root 3. We haven't really seen one exactly like this one. Okay, but hopefully you're looking at the numerator, okay? And hopefully you're looking at the numerator and you're thinking, wow, that's cofunction. Okay, so sine of 90 minus theta. Okay, on your identity sheet it probably says pi over 2 minus x. All right, so what is sine of 90 minus theta? Okay, that's cosine of theta. All right, now what do you have? You have cotangent. So cotangent of theta is equal to negative root 3, okay, which is very similar to tangent of theta is equal to negative 1 over root 3. Now, when you get to the next part of this problem, if you could get kind of a little bit mixed up on restricted range, but it should not affect your general solutions. It may make them look a little bit differently the way they look, but they should be equivalent general solutions and your values in the end should be the same. So this is a fine step right here. You don't have to worry too much about that. If you wanted to be really thorough and use the principal value with the correct restricted range, you would want to make sure you're using the restricted range for cotangent, not tangent, but this is fine the way it is, and I think you're good to work it out from here. Okay, so bring your questions to class. You're going to have a lot of these equations to work through, and it's just going to change from problem to problem what you do.